Hello and welcome, everyone. I'm joined by Tom Honeyman, Dr. Tom Honeyman, Professor Diana Cook, Dr. Sivandi Kandanarachi, and Professor Dan Simpson. So thank you to all of our listeners that are joining us. In this ASEMS panel discussion, we will chat about open source software development and the promotion of the idea of researchers producing software. So we'll have a wide-ranging discussion on how it benefits researchers and others, and the effect on career development and research impact via software, and importantly, what could be done to increase the uptake and usability and getting recognition for this work. So I'm going to go around the room and introduce the speakers and ask them to give a 5-minute introduction on themselves and how and why they became interested in software. So Dr. Tom Honeyman is the software program manager at the Australian Research Data Commons, or ARDC. And this is an initiative that helps enable the research community and industry access to collections of high quality data, infrastructure, and skills. So Tom, how did your research journey start? Software journey start?
Well, it's a little bit of both, really. I don't want to go quite back to the moment of my birth, but I did first start programming when I was in high school, and I've always loved languages, both human languages and programming languages. And I got completely obsessed with developing a Japanese teaching tool in HyperCard. And that's how I cut my teeth on programming languages back in the 90s. So I went on to university and did a science arts degree at Sydney University, majoring in computer science and linguistics and Japanese. And when I graduated, computer science was the special sauce that I brought as I continued to work in linguistics over many years. So I've had a string of jobs working as a programmer on a lot of humanities projects in linguistics and anthropology in particular, and also doing functions like system administration. Also was involved in the archive space. So I worked for a while in the Pacific and Regional Archive for Digital Sources in Endangered Cultures, which is a multi-uni archive in across, ANU, University of Melbourne, and Sydney University. And so archive thinking actually is a strong influence on me, and it's a strong influence on how I think about software as well. And but I went on and did my PhD in an obscure language spoken by about 5,000 people in Papua New Guinea. And on the other side of that, went back to my passion in data and archiving, and worked for the Australian National Data Service for a while, which then later became the Australian Research Data Commons, where I started the role of software program manager. It's a bit of an awkward name, but I am a program manager of the software program at the ARDC, and that program is looking at recognition of research software as a first-class output of research. And that's what brought me here today.
Thank you. Wow, what a range of languages. Thank you. So next is Professor Di Cook. She is an ASEMS Associate Investigator and Professor of Business Analytics in the Department of Econometrics and Business Statistics at Monash. She's a fellow of the American Statistical Association and an ordinary member of the R Foundation, and with an impressive track record of supervising incredibly successful PhD students, thinking about Hadley Wickham with ggplot, UHI, Tsai with Markdown, both winners of the John Chambers Awards, and we've got Carson Sivert and Yuro Wang to add to the list, and I'm sure many more to come. These tools and interfaces actually make for the bread and butter of programming I use in R, so I see myself as a beneficiary of your work, so thank you. Di, I'm curious to know more about your story. How did you become involved?
Thanks for the introduction, and hello to everybody here. A lot of familiar faces and a lot of new faces. It's lovely to see. So again, like Tom, I don't want to go back to date of birth, but actually really the moment that I probably got started in programming was in the USA. Professor Javier Cabrera introduced me to a Sun workstation. If you don't know what that is, look it up, because that I think is the starting point of being able to integrate graphics and statistics and statistical modeling. Amazing machines with very high-end graphics for that time, as well as ability to compute lots of things. So I learned, well, it's also always a time for a language called S, which preceded R. And so I started learning coding with S. And then in order to work with the Sun workstation, I needed to learn to program in C. So all of this was done on the basis of looking at other people's code and trying to follow what other people had done and just tweak it. So it's I haven't ever been trained to code. And particularly in my undergraduate degree in mathematics and statistics, we didn't do any coding at all. And so it's really self-taught. And a lot of what I've learned from the people around me, in particular the students. I've learned a lot from those students that you mentioned, and many others. Kyung Lee, who's in Korea, was actually the first student that taught me a lot of things. But one of the key things over the years is that some of the most impactful people that I've worked with are people that have coded. And unfortunately, over the time, many of my favorite academics have dropped out of academia, partly because they didn't get credit for the work that was really being used by so many other people. And so the importance of software for me has just been increasing and increasing. And I am becoming a better programmer as the years go on, actually.
Thank you, Di. And I really love that sentiment of learning from your students as well. I think that's a very humble way to put it. On to Sivandi Kandanarachchi. She is an ASEMS associate investigator and researcher working in data science and analytics, in particular anomaly detection and event detection with applications in complex data, motivated by real world problems. So Sivandi, would you please tell us about your story?
Yeah, thanks, Katie. I did, so I'm not a natural programmer. I have to confess that. I feel like I did my first degree was in engineering, and I was employed as a software engineer. And I have to confess, I didn't really like that. I don't know, something about it. I probably because it was the things we were doing. I think, like, looking back, it was more like building systems for supply management and that kind of things. I wasn't really drawn into it. Later, I did my PhD was in mathematics, and then I was not doing software at all. I thought software was out of my life forever. But then after that, I came to the econometrics and business statistics department at Monash, where Rob and I worked. And then I saw, then again, the software kind of, it was to do the mathematics and the statistics that were using the software, not to do like the boring supply management systems, So then it was all of a sudden, oh, wow, this is great. This is exciting. And of course, the atmosphere there was so encouraging. And initially I had lots of doubts. Will I write a package? How do you write a package? All these questions. And there was like this hesitancy, maybe later, that kind of hesitancy. But the atmosphere at EBS was so encouraging that, I started reading about it and did it. And in the end, I found, oh, that wasn't that hard as I thought it would be. So yeah, that's my journey. And right now, I really like making packages and making the work available.
Thank you, Sivandi. I really love your comment on the maths being the exciting part. So Professor Dan Simpson is the Director of the Analytics Engagement and a professor in the Department of Econometrics and Business Statistics, also at Monash University, and an ASENS Associate Investigator. But perhaps what I and many other programmers here today know you most for is being a developer and maintainer of both the R, INLA and STAN packages. If you don't know what they are, they're widely used software projects to help Asians do their thing. So Dan, tell us about yourself and what led you to where you are today.
Hello. So I am an adequate programmer, and I was a mathematician. I did my PhD in numerical analysis. So I thought MATLAB was the single greatest thing that had ever been invented, and that sharing your code, I mean, why would you do that? Because you could just do it yourself. I wasn't a great numerical analyst. So I my work kind of touched statistics a little bit. And I sort of drifted through the postdoc land, and one of the places that I landed, sort of the second place I landed, was in Trondheim in Norway, where Håvard Rue had written the INLA software. And I had this strange combination of pieces of knowledge about how computational things work that was useful for him at the time. And so I got a job with him and I started working on INLA. We started expanding it with Finn Lindgren to do sort of spatial models. I started to learn two things. One of them was that Håvard is an infinitely better programmer than I am. The second was that Finn is also an infinitely better programmer than I am. And the third thing is that to have software that people use is to maintain an active community. And I started to learn things about that and about how software and the community around software can be integrated into your research practice. I then wandered off and sort of continued doing INLA-y things, and eventually just sort of got too busy and I sort of fell away out of that world. We still do things occasionally. I still love coming home to INLA. It's a wonderful thing. And I accidentally fell into STAN. So I have a terribly good luck about projects. I actually had some spare money that was going to go away if I didn't use it. And I've always wanted to go to New York. I like Broadway. I thought, well, Andrew Gelman seems like a nice person. I'll see what happens. So I wandered over, and it turned out to be the beginning of a very fruitful research collaboration. And I just sort of, because that was sort of STAN was the thing that was happening at Columbia at the time, that just sort of became what I was involved in. I gradually became more and more involved, particularly in sort of behind the scenes stuff, the design stuff, the governance side of it, the community side of it. I was on the NumFocus board, which dealt with the funding of STAN, and on the first sort of STAN, I can't remember what it was called, STAN SDG, no. You know that thing where you don't remember what acronyms mean anymore? It's been a long pandemic. I was on whatever the government board for STAN was for a sort of a couple of years, and sort of all of that kind of got paused by the pandemic and is sort of slowly coming back to life again, which is very exciting for me. But yeah, I sort of fell into this and it was weird.
Thank you, Dan. I suspect you're a very humble person too. And I love that sentence. You said software is to maintain an active community. No, I really like that. So with that, let's get started on the first question. So I thought it would make sense to start with, what are the benefits of open sourced software for researchers and end users? And Dan, can we start with you?
Absolutely. So, I mean, for me as a researcher, which is probably different from other people as a researcher, being involved in open source software has allowed me access to how other researchers think in parts of their sort of workflow and parts of their practice that I would not ordinarily see. So when you're developing the tools that people use to do sort of the low level stuff that they're working with, when you're helping them with that, when you're sort of doing sort of tech support and just generally chatting with people, you find out a lot about their practice. And it sort of pivoted my research into research in the practice of statistics and how people actually do stuff. I think from a user point of view, open source software is available. I joked before about MATLAB. I fell out of love with MATLAB essentially immediately when my license expired and I had a paper revision to do. I never fell in love with Octave, which is a lovely piece of open source software, but not one that worked for me in that particular scenario. And so I think convenience and the ability for people to use it and to use sort of new tools and to be guided through best practice by the design of software and the documentation of software and the sort of the people around the software is a huge possible advantage to people who, just use research open source software.
So this question's to the panel. Why open source software rather than monetizing it and potentially using that money to fund further research?
Actually, could I answer the previous one first?
Yes.
Okay, so I'd like to make some comments on the benefits of open source for researchers and end users and just general public too. So I do like to use the catchphrase today of what I can do, you can do too. That's an important thing for today's world. It wasn't the case 20 years ago when people had specialist computing devices, but mostly what we do, almost anyone has the tools to do what we do today. So that's a really important aspect of education. As an academic, it is our mission to educate. And the other part of it is, I think it's especially important today, and particularly in the last few years with the prevalence of conspiracy theories and theorists. I feel like if you're just talking about your work, it is equivalent to being a conspiracy theorist, because you're just expecting people to believe you without providing the evidence and the support behind what you're saying. And I fear that academics are guilty of this extensively. And it's time that that's changed, because the landscape is possible that we should expect evidence behind all the statements that are made. I've got more to say in the next question as well.
Well, why monetize it?
So I'd be happy for somebody else to jump in as well. Maybe this is just brief. There's been a lot of open source software that has been monetized. You have examples like Tableau, and early on, a competitor to some of the work that I was doing in the 90s, Spotfire was a very successful commercial graphics program prior to Tableau that was actually supported by the Swedish government. Actually, the Swedish government really monetized that one. But so there've been quite a lot of successes, and there's no reason not to monetize. I would say that there are routes for that, but not everything can be a moneymaker. But if you're interested in that, most universities, I think, have groups that would help you get started to try to sell your work or set up a business plan. Other than that, there are many other business partners that you could engage with to help. But I think as an academic, you definitely needed some partner to help you get started in the business world.
Any further comments?
Yeah, I guess I wanted to say that having open source software and monetizing it are not mutually exclusive things. So it is possible to have openly licensed software. And I think the other point I wanted to make is the distance between you laying down that first idea as code and considering whether you want to do it in an open way or not, and the possibility of monetizing it. It's actually quite a bit of distance and ground to cover there. And so it's not really necessarily a question that you may well be thinking about it at the start, and you may want to set up your licensing arrangements in a way that enables that. And again, you can do that as open source software and consider that down the road. But in all likelihood, you are going to be doing open source software for a period of time before it starts to look like something that could be monetized anyway. So you can just make it open to start with, might be the way to think about it.
Okay, so on that note, and circling back to open source software, so how do you release it so that people can find it and use it? Guy?
Sure, I'm happy to jump in there. So the first step is to have your work on GitHub. That's a standard place where other people can find your work and give it a star or report an issue or start a discussion. And then secondly, definitely with if you're working with R, a package down website associated with that GitHub repo. And both of these things are actually really quite easy. And I think Savandi might talk about that in a little bit. And then beyond that, to the big archives like CRAN and Bioconductor, many of those have automated systems, or there's sort of automation around them where there are blog posts and publicity related to new releases on those archives.
Okay, thank you. So we've spoken about the mechanics of releasing software, but what are the perceived barriers to making open source software? Savandi?
Yeah, Katie. Yes, there are perceived barriers, but I also wanted to add something to the previous question with like, why make it open source? I feel like most of the time we're doing research using funds and sometimes most of the time taxpayer money, and then we would also like to give something back so that anyone can use. And the papers often the papers that we publish, of course, most of the time we put it on archive so that anyone can have a copy, archive, or any free repository. And similarly, here's the code if someone wants to use it. So I think it ties well with that as well. About the barriers, I think one of the main things is the mental barrier. That's what I had, because, okay, you're doing your research and you're doing something and you've got an algorithm or a procedure, something that you have code. Most likely you've already coded it, but it's not at a state where you're happy to share. It's not packaged nicely to be shared. And there's a learning step there. And in our minds, we think, oh, that's so hard. Oh, would I be able to do this? Oh, another thing to learn. So there are these barriers. But once you with the programming languages that most people code today, I'm talking about the data science side of things. It can be R or MATLAB or Python. There's plenty of documentation available. R is fantastic, and there are ways, like really nice documentation that'll help you. How do you make this a package? And they're not really that difficult. It is, it's only, the biggest barrier is the mental barrier. It's not the barriers are not the coding part or doing things, because there are lots of help available there. They're actually very small. I want to emphasize that the barriers to entry are really small.
Okay, thank you.
Can I respond to that as well? I just also want to point out that there is an intermediary step between not sharing your code and submitting it to Package Manager, which is the notion of snapshotting your code upon release or at different release points, there might only be a single release of the code that you're doing, particularly if you are just getting an idea out there and you're not vouching for its stability or anything like that, but you want to turn it into a form that is properly citable and trackable, then there are mechanisms out there, for instance, for snapshotting code that's being actively developed on GitHub. in Zenodo or, at Monash in particular, you can actually snapshot your code into Figshare if you want to as well. And what that will do is give you a DOI. And that's a really important part of tracking the ongoing use of that software as well, because it allows the bibliometrics wonks to look for that unique string and count uses of that software, at least in the scholarly literature. Now, that's not incompatible with then later submitting it to a package manager as well, but it's a really interesting intermediary step for, making it more like a first-class object in the system. So similar to what we're starting to do with data.
Okay, I think I lost connection for a bit there, but I'm back. So basically, what we see in the literature is a range of different software development kind of. So there's people who have these packages and actually link that. So there's publicly available code, and then there's still people who have please email the author for code. So when is it actually necessary to put our article code in an open source package? Dan?
Always. I think is the like increasingly the answer to that question. One of the top statistics journals, JASA, Journal of the American Statistical Association, now requires open source code where feasible. And the where feasible part is, of course, is important. You can't if your code is in some sense human sensitive, it is possible that your code could disclose information that should not be disclosed, in which case that code should absolutely never be shared. That's basic research ethics. But most of the time, our code doesn't touch that. As a sort of a minimum product, an example of your research code that runs on data that is fake but non-identifiably like the data that you actually ran it on is sort of a minimum product that you need to share. I think that Di talked about conspiracy theories before, and I think, I don't know, I think the language around this can get very fruity, might not be the best word to use, but it can get very extreme, and you've seen that in sort of the open science area, and there's a sociological issue here, but it does become problematic when people can't reproduce even aspects of what you've done, especially if you're a methodological researcher or a computational researcher. It can be, there's a difference between a method that works and a method that worked on that very well chosen problem. And you can't really diagnose those things. You can't successfully review those things without it being shared. So I think it is, sharing your code is considerably more important than a proof of correctness in a statistical computing paper, for instance. Because lots of proofs of correctness are optimistic. The constants, they are large.
I'll jump in there and I just want to make a comment on, there's a difference between submitting your code as supplementary for a paper. That might be sort of more lightweight and be very tied to that paper. But the benefit of making your code into a package, beyond it being easy for other people to use, easier, is that it actually will help you conceptualize out the key methodology behind the work that might be generalizable to many other problems as well. That's a very useful exercise.
So how do you get recognition for this work as an academic researcher? So how do you get academic credit for research software for promotions or grants and all that? Savandi?
Ooh. Well, I think uh, so. My understanding is that there's this impact section that you can like sort of software can be counted as research software can be counted as like a pathway to impact, because impact is if someone has used your work to do or modified it, or there's a big definition. And then I think it is like a pathway where you're making it available for others to use it. And it's not necessarily in academia that people use it. Someone in industry can use it. And if it has good documentation, as Di said, having a website and a packaged down website, so the documentation would help sell the software and explain to a person what it is. So I think look, I don't have lots of experience in promotion or getting grants and things, but my understanding is that increasingly people are putting software for grant applications and saying, and because in grants there is a section saying impact beyond academia or something like that. Like, you know, it's beyond, it's not the citation. So how are you going to talk about that? Maybe Di and Dan can comment.
I have a lot of things to say about this, really, from experience, but I'll start with it's related to maybe one of the other questions that have been asked. The first step is getting a job in academia, and I have to say the things that we look at, or I might not be speaking for everybody in our group, but definitely me, I look for a GitHub site for all applicants that are potential candidates for a position, and a code. And then I look at the citations in the papers that have been published. If they have not cited the software that they use, particularly you can see that when there's a ggplot2 plot and there's no citation for ggplot2, that's a clear giveaway. Then that says that they don't have the right state of mind for the group that we are putting together at Monash. So that's first. And then the second, when you go through the promotion procedure, even if it's not one of the bean counts, often qualitative information is considered by promotion committees. And so I've always listed all the non-traditional research outputs as part of my promotion packets. And in particular, the very first promotion packet that I put together, there were half a dozen VHS videotapes. I don't know whether you remember what VHS videotapes, but I put a box of videotapes in for the committees going forwards up the rungs at the university. And while that wasn't necessarily gelled with the department, it definitely gelled with the provost and the president of the university. So, and on the flip side, when I served on promotion committees in the US, I also have rescued a few cases that have been put in the bin because people didn't know how to review that work. Particularly, I know, Tom, your background is linguistics. There's particularly an young English researcher, I forget his name. He had very few papers, but he had set up the most unbelievably amazing sound studio in order to do audio research. And I just thought that was seriously creative and bleeding edge, as far as it's likely to mean that many other people will follow that direction of research. And the provost agreed with me. And so that case went forward. It wasn't, so this is the flip side, is it does also depend on the committee that's reviewing the case. Very much so. We're still on a basis of people, evaluating people, even though we are doing more computer automated evaluations, still it's people evaluating people. And the constitution of those committees is really important, which says to people like me who have already made it through the ranks, I should jolly well get on to some of these committees, including ARC. But there's only so much one can manage. So those are the comments that I have.
Dan?
I completely agree with Di. The way that you get credit for your research output, fundamentally, whether it's given or not, the only way to get it is to ask for it, to document things, to get feedback, to get testimonials, kind of like the way that you document your teaching. You document it through some amounts of sort of feedback and bibliometrics and surveys, also testimonials, also people looking at your work. All of this sort of stuff is fully possible. And I guess sort of on a bigger picture, it's disappointing is not the word that I should use here. I think the one I'm looking for is closer to pathetic, perhaps, that this is a conversation we are having now, that this has not been spearheaded by senior academics across Australia and across the world, that we have one department that has a formal way of recognizing research output, and that came this year. And with a lot of work, and I don't want to say anything bad about the fact that it was a lot of work to get done, but this should have been a lot of work that is getting done everywhere. It is the responsibility of every senior professor, whether they do software or not, to get off their ass and get the faculties and get the universities to build processes that can recognize work, because otherwise we're just draining the talent pool. And who wants a shallower talent pool? This is like every university. You can't move without a new Institute for Data Science. You can't move without some sort of strategic plan that is talking about impact and talking about data and talking about analytics. And yet there is no follow through. And that's on us. It's not a thing like, oh, I wish this could happen. This only happens if the level E's, the level D's get up and make it happen. And particularly, organizations like ASIMS and people who are not directly affected by it, because you have colleagues, you have junior colleagues, and you will continue to have junior colleagues that are being affected by your inaction. Anyway, that was my rant for the day. Sorry about that.
Yeah, I mean, yes, basically. I think the status quo we're in an argued case for getting credit for this thing. And the change that we're seeking is an acceptance of what is normal practice within scholarly communities. And so you have to look to those mechanisms for, if a funder or an institution knows that all researchers of a particular kind treat software as a first-class output of research, then that's when policies change and reward and credit systems change as well, because it's just keep catching up with what's normal practice. I wanted to say there are a couple of things, a couple of tangible steps that perhaps attendees in this session could do is join the Research Software Engineers Association of Australia and New Zealand. That is a peak body for people who create research software in Australia. And one of their stated goals is career recognition and pathways as well. And they operate across Australia. And the second one is to think about making your software citable in a way where what you are citing is not just the paper that accompanies it, but the software itself. So only when it becomes normal to directly cite the software that you're either providing or that you're building on, that you've modified, that you're doing, will we start to think of software as a kind of uniquely actionable form of knowledge representation, a way of expressing your ideas around which you are building a body of knowledge. And so that's how we make those changes happen. So that's me done.
Thanks, Tom. So we've mentioned this term first-class research output a little bit. So I wanted to talk about this and then circle back to recognition from a software engineer perspective. But first, there's been recent development in Monash University regarding software as a first-class research output. Could we have, could you please speak to that?
I was just going to say, maybe we can throw that to Rob, who's quietly hiding in the, who really spearheaded the effort. Maybe he can.
Yeah. Well, I'm not on the panel, but I'm happy to talk about it. So we managed to convince the business school at Monash that software was a valid research output and should be counted along with papers for promotion and probation purposes. And so if a person goes up for promotion now, they can list software along with their papers and they will get peer reviewed. So papers are already peer reviewed, of course, by virtue of appearing in certain journals. We're going to do the same thing with software, and they will count therefore towards promotions. We think we're the first department in Australia to have done this, so I'm pretty happy to have been involved with that process.
So for those who didn't quite catch it, what does first-class research output actually mean?
I think one way of defining it would be research output that is considered by the university as being as valid as a paper in a top journal. So for whatever reason, that is our standard of thing. So valid as a paper in a top journal, valid like a sort of a colloquium or a sort of a keynote speech, those sorts of things.
I think the term, at least just the way that we use it at the ARDC, might have actually originated out of either computer science or maths. And what we mean by a first-class object is that it is an object with all the features of other objects within the system that are treated as sort of the primary objects. If you like, that's a bit abstract, admittedly. But, obviously scholarly articles are first-class objects in the system. They're well recognized as being a necessary component to being an academic. And they have lots of policy and promotion and process ramifications. There are complicated systems set up at universities that allow them to track these outputs and understand what's going on. And as a researcher, these are kind of the fundamental units that follow you through your career. And so lifting research software into that status means that they would have all of the same features. It's not just meaning that we treat software as articles. That's not what it means. It means it is at the same status, if you like.
I'll add to that, ultimately, I think what we're trying to measure is the effect that work has on how the world runs. And so to me, it's maybe a little bit too strong, but it's something that really solves a problem that nobody else has done, changes the field, or adds new directions, or leads to new and better practices. Now, measuring that is hard. And the ad hoc, or I shouldn't say ad hoc, but the substitute measure is to measure the quality of journal based on rating factors or based on people's opinions of journals, which I think is a pretty badly biased estimator, or pretty badly off estimator. So I'm really, really hoping that we can push the envelope further in getting closer to the mark with recognizing and measuring other forms of output.
I mean, if I can jump in on the back of that, I really like pushing the idea of code availability more broadly, which is sort of harmonious with open science practices, because I really see that as the connective tissue between the scholarly impact of a particular study that might have utilized someone's software and that software. So if we have greater code availability out there and we can see the breadth of software that they utilized in the form of software to do their analysis, then we can make these connections between people who are providing them, methods and other tools for doing research that are used across a broad range of research areas, and the actual impact that work had. So that is how we connect, statistical methods to impacts in all these other domains as well. So that's another way I think it could happen.
And going further on that idea, Tom, what are the national and international policy drivers that can help with recognition of research software as a first-class research output?
So we've had two big ones in the last year. Just very recently, there was the UNESCO recommendation on open science, which has been adopted by the council very recently. And that's quite clear on the position of software as scientific knowledge and making it available. And the second one, which possibly has more teeth for Australia, is the OECD recommendation on, oh gosh, the name of this one always slips me out, but I think it's access to data from publicly funded sources. Maybe you have to rearrange the words in that to get to the exact recommendation, but it's got all of those words in it. And in that one, you have a clear call out to make your code available. And it actually goes further and talks about how we actually need to develop a workforce that does this, think about the division of labor across these areas. It specifically names research software engineers as a necessary part of the overall workforce, for instance. And because Australia is a signatory to that recommendation, it's sort of like soft law for us. We have an obligation as a nation to attempt to implement the recommendation as well. And locally, what we have is if you look at the Australian Code of Conduct for the Responsible Conduct, the Australian Code for the Responsible Conduct of Research. I'm mangling the words again. There are some mentions in there of software, but you do kind of have to read the tea leaves a little bit to appreciate where they're going. We do have responsibilities under the code to make available our methods and in a kind of research integrity sense that we need to make available code. And there's also within that, which I guess is a sort of a question that hasn't necessarily come up, but the idea that we should also be acknowledging these contributions. So if you're the programmer in a research project, but not necessarily the lead author on a paper, then you should still be acknowledged as contributing to that body of knowledge as well.
So this leads in to a good question about research software engineers. So how do they navigate the perils of requesting proportionate recognition of their efforts without becoming self-aggrandizing? Dan?
I think that it's impossible to be self-aggrandizing while asking for proportionate credit and appropriate credit. And I think there's a tendency for certain types of people in academia to gaslight us into not asking for credit that is reasonably deserved. And we should resist that strenuously. So my answer is ask. If you're in a more complex relationship, if it's you're straddling that boundary between technical advice and collaboration, then you need to explicitly talk about how you're straddling that boundary and what is the expectation. You need to have strong and reasonable boundaries that are articulated. And we need to develop community norms that let that happen, because otherwise you burn out your software developers and they go and get a much better paid job with stability.
Thank you, Dan. So still on the topic of research software engineers, how do you attract them? We spoke a little bit about retaining, but how do you attract and retain them so that they want to stay?
We're really getting into the hard end of the questions now. I think that one of the critical things is that software engineers are expensive. And some people don't realize this, but a fully qualified software engineer is a highly skilled job. There are grades in between that as well. But if you're serious about having software engineering expertise in your research project, then it actually means stumping up the money to do that. Yeah, I don't want to hog this question though. I think there was some really good answers.
I can make a comment there too. I'm in sort of two minds about research software engineering positions in academia. I think in some ways it's a fabulous development. There's some historical examples like Naras Balasubramanian. I can't say the last name, but we just call him Naras, who's at Stanford University. I'm partly in two minds about this because I lived through the times in the 90s and the early 2000s where anyone who was actually able to work the computer sort of got bundled into that position and mistreated, when they could well have been measuring their output as academic output and promoted in the same way that academics doing no software development were getting promoted. And so we lost a lot of people from academia that had those skills. So to me, it's a little bit of a double-edged sword. And I definitely have experienced that myself, of being targeted to my initial choice when I went to Iowa State as a new PhD graduate was to go into the Statistical Computing Center because they had actually a statistical computing group in the department. And I deliberately said no, because I think that's allowed me to have a longer academic life, because I deliberately made choices to say, no, I'm a regular academic and you need to measure me that way. And so it sort of, as long as it then gets valued in the system, we're good, but it shouldn't just be considered just because you have a research software engineer in a department, oh, they get thrown all the software development. If we're going to have a system like that, I think a model of the Monash Bioinformatics platform is a really nice one. They have a sort of a motto that they're not going to feed you a fish, they're going to teach you to fish. And so that type of position, if you end up being in the software development position, you have to be very careful not to be abused. Generally, it's a very tough, I think, role, but making sure that anyone that comes to you actually learns from you as well is a really important role. I don't know whether I've said that properly, but I've had some horror stories in my past.
Andy?
Yeah, I think for a person who's applying for such a job, the research software engineer, I think it's really good to know what the culture of that department is, and you know, so Danny's nodding. So like obviously at EBS, they're valued staff member, and you know, so you want to do that research before you jump in, because what Di said, it's gold. Like, you know, you have this other side which you don't want to kind of fall into.
It's really complicated because the jobs that exist don't have career progression associated with them under most of the models, and they don't have a clear source of continuing funding underneath them. Which means that in order to continue your job, you either have to find your own funding, or you have to, in some sense, abandon your agency in choosing the projects that you have. And that becomes challenging, and that really becomes it's a structural problem that we need to address if we want research software engineers to be a job. As Di said, there's a lot of potential for mistreatment here. But on the other hand, there's a lot of potential for growth in a career. So I was, heavily involved in the STAND project, and one of the things that the STAND project did was paid software engineers not professional rates, because they're in New York and it's America and they all earn sort of $500,000 minimum, and no academic can pay that, but paying considerable wages, as decent a wages as they possibly could, to people with the promise of freedom, with the promise of training. A number of people used it as an opportunity to skill up or to change skills. That is a possibility that can be used here. A number of people went on to sort of spin it into consultancy practices and things like that, where they still work on the side, a little bit of sort of software development, but then it becomes sort of more ordinary open source contribution. A third model was, which is sort of unique to projects of the size of STAN, some companies would construct positions for people that would have sort of 1 day a week as a developer and 4 days a week implementing the sort of the things that the company needed. And you see sort of versions of those models for people who are essentially research software engineers, or on the border of research software engineers and professional software engineers, across a number of the largest scale academic projects. You see it in obviously STAN, PyMC3, you see it in Julia, you see it across these big ones. It is notable that all of those are run by Americans. And there's a lot of structural flexibility in that. Lots of spare money. But yeah, so it comes down to money, it comes down to intentionality, it comes down to having a path, whether that path is to continue to do research software engineering or to transition it into something else, be it into research, be it into software engineering, be it into training, be it into consultancy. It really is it can be a real opportunity if the people who are constructing the position make it one.
And can I just tack on one thing? It also comes down to the research domain that you're in as well. So all of those things plus the division of labor that happens differently across different research domains as well.
So I thought a really nice way to finish up in the last minute is to go around the room to our panelists and offer an opportunity for some closing thoughts. How open source research has impacted your career, for example. Tom, can we start with you?
Look, I have to reiterate your like of Dan's quote earlier, which is that maintaining is an active community. I am going to steal that one and keep using it. And I will also say, like, the thing that yes, and correctly cite him. And then the other thing is that I really am. I really do love this move that Monash has made, or Monash Business School has made, to recognise research software in this way, and I will personally be picking that up and carrying it around the nation as well, as a great example of change.
I'll jump in as a last thing to say. Give credit and kudos to Software Outputs, and pay well, because people with these skills can easily earn big salaries in industry and outside, and we need them in academia.
Dan, you're on mute.
Someone had to do it. Honestly, I think that sort of the history of research software engineering and software as a research output is like a long sequence of snatching defeat from the jaws of victory. And I'm glad that we're slowly stopping that, but it's an enormous push. And I can't emphasize enough, it can't just be a push from people like Di and Rob, who are sort of at the peak of their career and doing really important software work and have been doing it throughout their career. It needs to be a push from the entire community. And without that, things just won't get better. I mean, I'm mildly optimistic that things might get better, but then we're nowhere near it yet.
Savandi, final thoughts?
Yeah, I want to encourage anyone today who's thinking, oh, should I write that software? Or, I've coded it, but it's not it's not at a shareable stage. Go ahead, do it. It's not that hard. You can do it.
I love that sentiment too. So thank you everyone for joining us. We're only 2 minutes over time, but that's fair because we started at 2 past. So the timing is perfect. Thank you all. And I hope we can talk about software again very soon.
Thanks, Katie.
Special thanks to our speakers, Tom, Di, Savandi, and Dan.
Thanks, Katie.
Thanks, Katie.
Thanks, Katie.